Okay, ma'am. So, ma'am, I just wanted to know, for some of us who did not start with inverse functions, can we just like watch maybe like one of the old videos, because I do watch them, and then
Absolutely. 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 Go and watch the old videos and then you'll be able to see exactly what's going on. 100%. 100%.
okay,
I
ma'am.
think also, Katlego, as long as you are there from the beginning, and you don't sort of end up joining the course 2 lessons in or 3 lessons in or 4 lessons in, then you'll be able to follow, because each time I see you, what I do, I build on what I've already done. I build on what I've already done. But yes, absolutely. I think that's such a brilliant suggestion. So for anybody else as well, if you haven't done inverse functions and you're not sure, then go and have a look at the old videos. Brilliant, Katlego. Thank you so much for that. Okay, so let's jump into what it is that I wanted to do with you this evening. And I wanted to just finish off this section by showing you some of the sorts of questions that they can give you in exams on Euclidean geometry. All right, and we're going to work through all of these together, but I'm going to call on you guys a lot to tell me what you think and give me answers and that kind of thing. I don't want it to be me standing here telling you what the answers are. I want you guys to sort of, participate and tell me what you think as well. Even if we get it wrong, it doesn't matter. It's not the end of the world. We've got plenty of time. We can still fix all of this. We must just all try and contribute and participate. I think that's what's most important. Okay, so the first question that they give us is they tell us that ABCD is a parallelogram. So that's important to us as well, because what do we know about parallelograms? I mean, apart from the fact that there are 2 pairs of opposite sides that are parallel, what else do we know about parallelograms? If somebody tells us something is a parallelogram, what else does that mean for us?
Ma'am.
Yes, Katlego.
Is it, I don't know what you call it, ma'am, because like, ma'am, we've been working with circles, so I don't know if you call it the diameter or something, but they like cut into like 2 equal parts, ma'am.
Lovely. Okay, so it's not called a diameter. They are called diagonals. Okay, but that's lovely. So the diagonals bisect each other. Okay, and that's just a very fancy way of saying the diagonals cut each other in half. So the diagonals bisect each other. So what that means is that AM equals MC, and it also means that BM equals MD. Very good point. Well done. Thank you so much. Yes, diagonals bisect each other. What else do we know about parallelograms? They have 4 sides and all opposite angles add up to 180 degrees. Okay, the opposite angles don't add up to 100. That's in a cyclic quad, but they do have 4 sides. The opposite angles are equal to one another. Okay, so that's different to a cyclic quad. So the opposite angles are equal. Okay, that's true. That's something else that we know. Opposite angles are equal, quite right. What about the opposite sides? What about the opposite sides? The opposite sides are equal and parallel, absolutely. So opposite sides are equal and parallel. Okay, so just because sides are parallel doesn't mean that they are equal to one another. All right, but in a parallelogram, they are. All right, very nice. That's probably about the most important things that we need for this particular question. So what I'm going to do is I'm going to jump in and I'm going to carry on with the rest of it. The diagonals of A, B, C, D intersect at M, so they cut each other at M. F is a point. So here's F over here, is a point on AD, such that AF is to FD is 4 is to 3. So 4 is to 3. E is a point on AM, such that EF is parallel to BD. So that's important for us as well. They're giving us some parallel lines. Okay. And they've told us that FC and MD intersect in G. The first thing that they want us to do, no problem, Dumasani. Okay. The first thing that they want us to do is calculate the ratio of EM is to AM. So go and have a look. Here is EM. AM is the whole thing. So EM is to AM. Which theorem do you think that they want us to work with here when they talk about EM and AM? There's two new theorems we've learned in matric. Remember, we've learned proportionality intercept theorem, and we've also learned about similarity. What do you think they want us to work with here? Which one of the two new theorems do you think they want us to work with? That's it. They want us to work with proportionality intercept theorem. Quite right. And when we work with proportionality intercept theorem, we have to identify the triangle that we are allowed to apply our theorem in. Which triangle do you think they are guiding us towards? Which triangle do you think we are working in? Matrix? That's it. Oh, you guys are so sharp.
Yep.
Well done, everybody.
Really
Very,
good.
very nice. That is excellent. Well done. Okay, very, very nice. They want us to work in triangle AMD. And we know that because we can see that EM is part of one side, AM is the whole side. There is the other side over there, AD, and we can see we have a line drawn parallel to the third side of the triangle. So line EF is drawn parallel to side MD, and it cuts the remaining two sides into the same proportions. So EM over AM equals what? EM over AM equals what? EM over AM equals what matrix? That's it, FD over AD. Well done, you guys are brilliant. FD over AD. And then what reason do I need to give? What's going to be my reason? Good, well done, Shoshana. Okay, I'm going to write here, proportionality intercept theorem. And what mustn't I forget to do? I mustn't forget to name the parallel line. So I'm going to write EF is parallel to MD. Okay, and now that I've done that, I can go ahead and go and sub in. So what is FD over AD equal to? Yes, Katleho says it is 3/7. Well done, Katleho. You are on fire. That is brilliant. Absolutely excellent. Well done. So 3/7. If you go and have a look here to the right matrix, they have given us the mark allocation. Oopsie daisy. It's just me doing some work on this earlier. They've given us the mark allocation. It's out of 3 marks. The reason it's out of 3 marks is because they want us to write what it is in proportion to. They want the reason together with the parallel lines, and then they want the answer from us. Okay, so I see somebody's got up a hand. You're welcome to go and ask your question, Mr. HEM. You're welcome to unmute and ask.
You can unmute on your side. Or we can continue until Hem finds out, but the unmute should be there. Maybe it's a mistake. And you can also tap on the chat.
Okay, so Nozipo, remember, AD is the whole side. So that's 4 plus 3, which is 7. Okay, so EM over AM is FD over AD. So the little bit FD corresponds with, well, not corresponds, goes with EM, and then the whole thing. So 4 plus 3. Okay, the whole side. Okay. All right, no problem. Okay, we're not finding angles, Mr. HEM. Okay, we're not working with angles, we're working with sides. Okay. Now let's have a look at the next question that they give us. All right, so here they say CM over ME. All right, so naturally we can get rid of this. And now let's go and have a look at CM. Okay, so here's CM. And here is ME. Okay, so CM is this bit, EM is this bit over here. Right? What do we think we should write? What do your instincts tell you you should write in this case? Aha. Now, Offense, I'm very glad that you said that, and I'm going to elaborate on what you've said. Nozipo, so ma'am, the numerator remains 3 and the denominator adds. So in other words, Nozipo, we have used 3 because FD goes with EM, all right? AM goes with the whole side. So that's from A all the way to D. So it's 4 plus 3. Okay, that's why. Okay, because it's the whole side with the whole side. Now, Offense, I'm very glad that you said that, because that is the natural thing that we would want to do here. We would want to write that CM is equal to CG over GF. And again, we wouldn't be wrong. It is equal to that. We've got parallel lines. We know that one side parallel to the third side cuts the remaining 2 sides in proportion. But the problem is that even though this is true, it does not help us solve the problem. All right. So in other words, we've written something that's true, but we know nothing about CG and we know nothing about GF. So I'm very glad you said that, Offense, because that is something that in this case, we cannot use. So now we've kind of got to go back to the drawing board and we've got to say to ourselves, well, what else do we know? If we know nothing about CG and GF, what else do we know? And it goes back to what Katlego was saying in the beginning, okay? The diagonals bisect each other, all right? Look at this. Over here, in the beginning, we said that AM equals MC. Sorry, I'm just going to have a look in the chat because there's a lot of you. There you go, Chloe. That's exactly what I was getting at. 100%. Okay, so everybody, if you can see in the chat what Chloe said, could we not just say that AM equals CM because of properties of a parallelogram? So no, you can't say properties of a parallelogram. Okay, that's not an acceptable reason. It's diagonals of a parallelogram bisect each other. Okay, there we go. Sean said it. Nice, good. Well done, well done, well done, well done. Okay, so you guys are on the right track here. We know that CM equals AM, so this is going to be the first thing that we have to write. So AM equals CM. Our reason, diagonals of a palm bisect each other. Okay, now that we've got AM equal to CM, it means that we know that CM is also equal to 7, just like AM was. So therefore, CM over ME, and ME is the same as EM. We would say that it is 7 over 3. Okay, so that's how we're going to do this one. Okay, it's out of 3 marks. The reason that it's out of 3 marks, Matrix, is because they want you to say AM equals CM, diagonals of a palm bisect, and then they're going to give you a mark for the answer. Okay, how are we feeling so far? Thumbs up, thumbs down. Lovely. Good job, everybody. Offense, what are you asking? How is it 7/3? Okay, so Offense, remember, we know that CM equals AM, right? And we know that AM was 7. That's how we know CM is 7. And then ME and EM are the same. So remember, from 1.1, we said that EM was 3. So that's why it's 7/3. Okay. All right, let's go back and have a look at the last part. Now, this is a not particularly difficult question. Angel, because AM is cut into the same proportions as AD. So AD is 4 plus 3, which is 7. So that means that AM has to be 7 as well. Okay, remember the remaining two sides are cut into the same proportion. Okay, so Miklali, that's why. Okay, you would be very confused. You are joining us in the very last lesson of our course. So everybody else, well, not everybody, but most other people have been here for the previous 5 lessons. So you are going to be very confused. Okay, that's why it's important to go back and go and look at the previous videos. All right, but just hang in there. We're going to be starting a new course next week, and then things will start to make sense because you'll be there from the beginning. See, what do you not understand about the 7/3? Okay, remember, okay, but see how we'll remember proportionality intercept theorem tells us, okay, that when we have a line drawn parallel to the third side of a triangle, it cuts the remaining two sides into the same proportions. So side AD and side AM are cut into the same proportions. So 4:3 is a proportion. Okay, so that means that AE is to EM is also in the same proportion, 4:3. So if we add those proportions together, it means that AM is 7. That's the total length of the line, written as a proportion. Okay, let's go and have a look at 1.3 now. Here they ask us to write the area of triangle FDC. Let's just get rid of these lines. FDC, so this is triangle FDC over here. And area of triangle BDC, so BDC is this triangle over here. First of all, I want to ask you, how, if we're not working with the area rule, how do we calculate the area of a triangle? How were we taught to calculate the area of a triangle in grade 7, in grade 8, in grade 9? How did they teach us to calculate the area of a triangle? That's it, half base times height, right? So the area of a triangle is equal to half base times height. So if I'm talking about triangle BDC, all right, and I want to talk about the perpendicular height, all right, I'm talking about the distance between parallel lines. So in other words, what I'm going to do is I'm going to draw a straight line from this line here down to that one there. That's supposed to be a straight line. That would be a perpendicular height. Okay. Because the base is meeting the apex at right angles. Okay, so the base of triangle BCD would be BC. The base of triangle FDC would be line FD. Their perpendicular height is the same, right? Because they lie between parallel lines. Okay, so if triangles lie between parallel lines, so if triangles lie between parallel lines, the perpendicular height is the same. Okay, so that is what we are going to use in order to be able to answer this question. Now, this is going to be something that is completely new to you guys, and I'm just doing it as an example, all right? So when we write the area of triangle FDC, right? So the area of triangle FDC, we write half the base of FDC is the line FD, because the height, that black line, is the same line. If I call this black line H, the area of triangle BDC, if BC is the base, we would say half BC times by H, which would be that black line. All right, anything divided by itself is 1. So now I'm going to divide that with that and get 1, that with that and get 1. So what I have here is FC over BC, FC over BC. So now I've got to go back and have a look and see what information do I have about FC and BC. Okay, so FC is this line over here. BC is that line over there. What can I say about BC and AD? Sorry, not FC. I beg your pardon. I made a mistake. I wrote the wrong letter. Just hang on, let me just correct this. Sorry, it's FD. FD. FD is the base. Sorry, that should be a D, not a C. That's it. So AD, BC equals AD. BC equals AD, absolutely. All right, so if AD is 7, then it means that BC is also 7. All right, well done, everybody. Very nice. So over here, I can say that AD equals BC because of the opposite sides of a parallelogram are equal. I know what FD is already. I know that FD is 3. This was information that was given to me. And I know that BC is 7 because of the opposite sides of a parallelogram. Okay, and that's how I would answer a question like this one. There we go. Perfect. All right. So this is, as I say, this is something that's brand new to you. Your teachers will do this with you when you do this section in class. There you can see it's out of 4 marks. It's 4 marks because they want us to state here that these 2 sides are equal. They want to mark for the answer, and then they want us to write the area of the triangles over one another like that. Okay. Fancy AF equals MC equals 4. No, so AF doesn't equal MC. AF would be proportional to AE. Okay, MC is 7, AF is 4 in this particular case. Okay. All right, let's go down and let's try this question over here. And let's see if this may be a little bit easier. All right. Nkaniza, have you done Euclidean geometry at school? Okay, so that's also why. All right, you need to go back and watch the videos. All right. There's, as we've said, many. Nkuniza, when did you join? Okay, so, but you've been here since the beginning of this course then? Oh, okay. All right. Well, you see, that's what's going to happen, unfortunately. The things that I'm doing now refer back to our first few lessons. Okay, so this goes back to what we did in lesson 2 and lesson 3. Okay, so that's where the exam questions are relating to, stuff that we did in lesson 2 and lesson 3. Okay. Maybe if you go back and watch lesson 2 and lesson 3, and then you watch this lesson again, it might make a little bit more sense. Okay, let's have a look at this one. This is a little bit easier than the previous question. You guys should be all right with it. Okay, so in the diagram, we've got triangle ABC, and K is a point on AB, such that AK is to KB is 3 is to 2. AK is to KB is 3 is to 2. N and M are points on AC, such that KN is parallel to BM. Very nice. Thank you for telling us that. BM intersects KC at L. We see that. And the other bit of information that they give us is that AM is 10, is to MC is 23. So we're going to go and fill that in as well. Here they say to us, determine with reasons the ratio of. And the first thing that they ask us for is AN is to AM. Which triangle do you think they want us to work in? So when they ask us to write AN over AM, which triangle do you think they want us to work in, matrix? That's it. Yes. AMB, BAM. Well done. Lovely, 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 lovely. Again, can you see we've got this line drawn parallel to the third side of the triangle, which cuts the remaining 2 sides into the same proportions. Okay, so we have to put things down clearly, and we would say that AN over AM equals what in the other triangle, or sorry, what on the other side, matrix. AN over AM equals Nkuniza, you saying you're confused, and there you've got the perfect answer. Well done. That's very nice. Okay, remember to write the side first and then your reason. Okay, good. Okay, that's it. AK over AB. That's good. Okay, so AK over AB. AK over AB. Reason, proportionality, intercept, theorem, because NK is parallel to MB. And then we're going to put in our answer, okay, and that is going to be 3 over 5. Okay, good job, everybody. Very nice. Well done. Oh, but you did that one so well. Okay, I'm really pleased. Well done. That was really lovely. Okay, good job. Okay, so let's go and have a look. That's what I was saying. This question is actually a little bit easier than the other one. All right, let's go and see if we can answer the last bit. Okay, so now they want us to write CL over LK. So let's go and have a look at CL over LK. Where is CL? Let's check. There's CL. So CL over LK. So there's LK in green. There's CL in yellow. Let's just get rid of the other green lines. Okay. So what is CL over LK? What is it equal to? CL over LK is equal to? CL over LK is equal to? Haven't seen it in the answers yet. CN, that's it. There we go, Natalie. Good job. Okay, yes, Yanela. Quite right. Lovely. So CL over LK is equal to CM over NM. Good job, everybody. Reason, proportionality intercept theorem. And again, we've got to name the parallel lines. Okay, so here it is because LM is parallel to KM. All right, so now there is something that is unknown. What is unknown for us here? Something's unknown. What do we not know? That's it. Very nice. Good. Well done. All right, so NM is unknown. We've got 23 over NM. So if we can solve NM, then we know the answer to the problem, right? So how are we going to work out what NM is? Remember, this is 2 and this is 3. That's the ratio. And remember, the length of AM is 10. So how are we going to work out how long NM is? It goes back to being able to work with proportions. How are we going to work out what NM is? Okay, so Lorato says that NM is 4. How did you get 4, Lorato? Can you explain that to us?
Renata, you can unmute and just explain how did you work it out? I'm also interested.
Hello, ma'am.
Hello, Lorato.
So, ma'am, I said NM over AM.
NM over AM, all right, lovely, equals?
2 over 5.
Okay, but okay, so what? Okay, so the reason that you're saying that is because it equals on the other side, it equals KB over AB.
Yeah.
All right, that's actually what you're telling me. Okay, very nice. Okay, so that comes from proportionality intercept theorem, and that comes from NK being parallel to MB. Very nice. Okay, so now you've got NM over 10 is equal to KB is 2 and AB is 5. Good job, Lorato. And then we're going to cross multiply. So that gives us 5 NM, that's a horrible looking 5, is equal to 20, and therefore NM would be equal to 4. Okay, so we've got to set these things out correctly. This is what they're expecting of us when we answer these questions. Okay, so we've got to be able to set it out the right way. A mark for that, a mark for that, a mark for that. And that means we're now ready to go and sub in here and get 23 over 4 as our answer. Okay, 23 over 4, Natalie. Okay, KB over AB is right. Okay, there we go. So 23 over 4 is the correct answer. Okay, so now we can see what they mean when they say the sides are in proportion, because Lorato has told us that that bit would be 4 and that bit would be 6. So we can see that they're in the same proportions. When we double 3, we get 6. When we double 2, we get 4. Okay, so very, very nice. This is the, okay, Nozipo. We're working back in triangle, AM, B again. All right, so we've said NM, this short little bit over here, over the whole thing, AM is equal to the short bit there over the whole thing. Okay, so then that makes NM the only unknown in the equation, because we know that AM is 10, we know KB is 2, we know that AB is 5, and then we can solve for NM. Yes, Sean, you've got a hand up, go for it.
Ma'am, in the question it said, didn't it say AC is equals to 23? Or is it
It said that MC was 23.
Oh, okay, ma'am. I just wanted to check
Okay.
that.
No, that's fine. That's fine. You're quite right. So up here, it told us AM is to MC is 10 is to 23. Katleho, go for it. Ask your question.
Ma'am, first of all, I just want to say, for some reason, I'm very unlucky because I just submitted my assignment and we had the same question.
Really?
But, yes, ma'am. But ma'am, they actually marked it wrong. So I don't know if I should ask my teacher because I actually gave the same answer, 23/4.
I wonder why they marked it wrong. Yeah,
Yeah.
maybe you must speak to your teacher. Yeah. Okay.
ma'am.
Oh,
Thank
Natalie,
you,
you
ma'am.
also had the same question. Yeah, absolutely. So this is why it's so nice for us to go through, excuse me, previous exam question. Sorry, because the same thing sort of tends to come up time after time. So yeah, very interesting that two of you have done the same question at school that we're doing over here. Oh, well, I'm glad that I brought these up. Oh, and Shane as well. Oh, brilliant. Okay, all right, cool. There we go. All right, well, hopefully then attending Watobe is going to be, and Nozipo. Wow. All right, so lots of you have seen this question. Okay, brilliant. All right, Natalie, go for it.
Oh, I see why I said 13/4, because in our question they changed the AM and the AC. They said AM is 10 and then AC is 23, so we had to minus it in our case, but then yeah, it's quite different
Okay.
at the end.
Okay, yes, so
So
they just
maybe
changed
that's why
some
she
of the
got it wrong.
numbers.
Because
Yes. Yeah, maybe they changed some numbers like they did for you as well.
yes, ma'am.
Okay, all right, there we go. Okay, brilliant. But there we go, same idea. Okay, so now what I want to do, I don't know if we'll get all the way to the end here, but what I wanted to do now was to show you how they put grade 11 and grade 12 together in a question. Okay, so here, the first part, sorry, this is part 1. So over there, and then this is part 2. In the first question, that is a grade 11 question. In 2A and 2B, those are grade 11 questions, whereas questions C and D are grade 12 questions. So you can see how they eventually start merging these things together, where now we've got a circle, we're talking about cyclic quads, but then we're also having to prove similarity. All right, so let's see how far we can get. Very typical sort of question that they ask us. Write down with reasons 3 other angles each equal to x. So first things first, let's go back and read the information. They've told us that ST and VT are tangents. So straight away, they're using the word tangents again. That's important to us. When we see the word tangents, what do we start thinking about, matrix? What does that take us back to? There we go. Tan chord theorem is the sort of main one. So we think about tan chord theorem. We could also think about radius perpendicular to tangent, or tangents from the same point. But the point is we need to start thinking about our tangent theorems. Okay, good. Yes. Exactly, Natalie. So in this situation, if ST and VT are tangents and X, this angle over here is the angle between the tangent and the chord, what other angle is equal to X? What other angle is equal to X because of tan chord theorem? Okay, so yes, in Kunaisa, V3 is equal to X, but that's not because of tan chord theorem. but you're quite right. That's it, Katlego. Angle R. Okay, so because of tan chord theorem, R is also equal to X. Absolutely. Now, Nkonizer was correct. V3 is equal to X as well, but why? Why is V3 equal to X? I mean, if we got R is equal to X first and then V3, but why could we say that S2 equals V3? What's the reason for that? There we go. Okay, so they are angles opposite equal sides. So TS equals TV because they are tangents from the same point. So that means that V3 has to be equal to S2 because they are angles opposite equal sides. Okay, so we're getting a few angles that are equal to X here just by knowing these few things. All right. What else is equal to X in the diagram? Can anybody else spot the third angle? So we've got V3, we've got R. What's the third angle? Can anyone spot it? You're very close, Sihawu. Not K3, Sishana. Not K2, not W1. Okay, so Nolutando, you said W2 and 3. Okay, why Nolutando? Why W2? Pagelo, why W2? Okay.
Ma'am?
There we go. Nakedi.
Oh,
Sorry,
ma'am?
Pagelo.
Sorry.
Pagelo, what were you going to say? Go for it. I want to hear what you were going to say.
Ma'am, I was going to say that W2 is equals to R because of the corresponding angles. Seems like there's...
Yes, yes, lovely. Good, Pagelo. That's why I wanted to hear what you had to say. Lovely. Okay, so there you go. There is your backbone. And there is your F lying on its side. And you are quite right, Pagelo. That means that W3 and R are equal to one another because they are corresponding angles. Very nice. Okay, because of the parallel lines. So here, just reading the rest of the information, R is a point on the circle, W is a point on the chord, RS such that WT is parallel. They don't really tell us too much more about the diagram. But now we are ready to go ahead and go and answer question number 1. So I can see there are some hands up. So let's just sort those things out first. Who's got a hand up? Okay, Natalie, go for it.
Oh, sorry, ma'am. It was my bad. I put it up by mistake.
That's fine. No problem, Natalie. Not a problem. Katlego, do you want to ask a question?
Hello, ma'am.
Hello, Katlego.
Ma'am, can't you say V2 is equals to X, alternate angles?
Okay, but V2, which lines are parallel for V2 to be an alternate angle? Because no, so there's no parallel lines with V2. There's not another, if we're going to make a zigzag here, there's no other line that's parallel to say WV in order for us to be able.
Isn't it gonna be from T1 to S2 as parallel lines, or?
Oh, so from T1 to S2. No, so we don't know that ST is parallel to RV. Okay, and it wouldn't be because ST meets WT, and WT is parallel to RV. So no, that's not going to be the case. The only alternate angles here that I could see that you might want to use in the future would be over here with W2 and V1. Those are alternate. You could also say that K4 and V1 plus V2 are alternate angles as well. All right, but that's not going to help us. Yeah, that's not going to help us at this point just yet. Okay, let's just rub those ones. No problem. All right, so we'll just rub those ones off. And now we're going to put down what we already said. Okay, so S2 was equal to X. Sorry, I'm writing the wrong thing here. It's not S2. We want to write R. Beg your pardon. So R is equal to X. And we said that was because of tan chord theorem. Okay, because S2 and R are equal to one another. Then we could say that V3 is equal to X. And again, we could use tan chord theorem as a reason. That is because the angle between the tangent and the chord is equal to the angle in the alternate segment. Or I could have gone tangents from the same point and angles opposite equal sides if I wanted to, but this is just faster. So tan chord theorem, and then the third angle we all decided was W3, and that was because of corresponding angles. And when I use corresponding angles as a reason, I mustn't forget to name the parallel lines. So here I need to say because RV is parallel to WT. And you'll see I've cut it off, unfortunately, but this was actually out of 6 marks originally. And that's because they were being kind to us here. They were allocating a statement and a reason and a statement and a reason and a statement and a reason. So that was them trying to be nice and trying to help give us lots of marks over there. All right, so Pagelo, you are saying, can we say that V1 is also X? Because, okay, so we don't know that W2 is X just yet, Pagelo, okay? It's going to be equal to X, but we don't know that it's equal to X just yet, all right? And that's because of the very next question, all right? We first need to prove that WSTV is cyclic. All right, and then we can say that W2 is equal to X because of angles in the same segment. But we don't know that WSTV is cyclic just yet. So we've got to prove that. So I'm just going to put some lines around. I think that's probably all we're going to have time for this lesson. But let's just put some lines around it. Okay, so we've actually already proved this. So we're in part 2A. We've actually already proved it. Can anybody tell me the reason why WSTV is cyclic? Why is WSTV cyclic? This wasn't out of much. It was out of, I think it was 2 marks, this question. It's not exterior angle. It's not exterior angle inclinator. It's one of the other 2. Nosipo, it's on the website at watobe.com. Nosipo, okay, if you have a look, ST is the tangent. Okay, here's the chord. And the angle between the tangent and the chord, angle X, subtends, is equal to the angle in the alternate segment. So you go from S to V down to R, it's tan chord theorem. Okay. All right, Nolutando.
Hi, ma'am.
Hi there, how are you?
I'm good. Can you say
That's
that
good.
V3 is equals to W3 because of the, I think it's angles in same segment.
You're on the right track here. No, Latondo, that's lovely. That's lovely. You're almost 100% correct. I'm so glad you pointed that out. Okay, so now when it comes to 2A, everybody knows that Latondo is correct. She has pointed out that V3 and W3 are equal to one another. And we know that. We've written it over here. So V3 equals W3. And the reason for that is because they both equal X. All right, so if they are equal to each other, it means that WSTV is cyclic. And remember, when we're working with proving a quad is cyclic, we have to use the word converse. Do you remember that, matrix? We spoke about this, gosh, all the way at the beginning of this course 5 lessons ago. All right, and this was converse angles in the same segment. Okay, so converse angles in the same segment. That's where it comes from. That's it, converse angles in the same segment. So we've proved that the quad is cyclic. Okay, now, unfortunately, because of my load shedding, we were a little bit late, so I'm going to do part B, and perhaps you guys can try C and D for homework. Let's just have a look at part B. I don't know if we'll be able to get any further than that. Now they want us to prove the triangle WRV is isosceles. So now we know that W2 is also X because of angles in the same segment. And then here we're going to use our alternate angles, and we're going to say V1 is also equal to X because of alternate angles. All right, so W2 is equal to X. Because we've proved this quad is cyclic, we can use angles in the same segment now. Because of angles in the same segment. Then we can conclude that V1 equals X because V1 and W2 are alternate angles. That's because WT is parallel to RV. So that means that triangle WRV has to be isosceles. Triangle WRV is isosceles because if angle R equals angle V1, it means that side RW, therefore side RW equals side WV. Okay, and that is because they are sides opposite equal angles. Okay, so therefore RVW, triangle RVW is isosceles. Okay. Sides opposite equal angles. So we've got angles opposite equal sides. All right, when we say TS equals TV, therefore S2 equals V3, then we've got angles opposite equal sides. And now we've got sides opposite equal angles. Because we're saying R equals V1, that means that RW equals WV because they are sides opposite equal angles. So if two sides in a triangle are equal, it makes that an isosceles triangle. Okay, so there we go. We've arrived at 7 o'clock.